Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on PVTP software, a very powerful software for fluid modeling, compositional fluid modeling. All right, in previous videos, we have completed this, pseudo properties section. And now we are almost ready to perform regression, where we hopefully can improve the quality of the matching for we hope that we can improve the match for almost data that we have in laboratory data. Okay, but before that we are going to take this moment to gain an overview of how well the current model, the current equation of state, reproduces the lab experiments data. And as the lab data has already been entered in the PVT sample object, direct comparisons can now be made. Okay, and taking the lab experiments in turn, we will go through the process of add appropriate calculation data object and running the calculation. Okay, so once again, before continuing on to the regression, we will first check, how well the matching is right now. Okay, and to do that, we will go to the calculation. And first calculation that we are going to do is constant composition expansion. So you go to here, calculation, and select constant composition expansion. There, maybe I can move this a little bit, there and there. Okay, so now we have the CCE, the constant composition expansion. Double click. Okay, and then let's input the temperature, minimum to maximum, just one value of temperature, thus number of values only one. But for the pressure, maybe we can go to the PVT sample first, enter lab data, and let's check constant composition expansion. Okay, so now we have from 185 PSIG to 3,985, almost 4,000. Okay, so let's input 200 to 4,000, and let's say number of values 50. Okay, we will create, the prediction, the estimation, the predicted curve for the fluid properties, and then match them, compare them with the lab data that we have. And then path to surface calculation method, flush straight to stock tank. Okay, let's leave it as default, and input data automatic, but you can also select the user selected, but let's go with the automatic. And for the CCE, we are only interested in the oil density and viscosity, and thus it is not required to specify a sparator train. All right. And if additional data such as, the GOR had been provided in the lab report, then the same separator train as used in the experiment would need to be specified. This is because the GOR is, path dependent, and thus using a different separator train would result in different GOR, of course. Okay, so we can click on calculate, done, and let's go to results plot and view the desired plot by selecting the variables from the y-axis. Okay, so let's go to PVT sample first. Let's see what we have inside the CCE. So in the lab data for CCE, we have data for temperature, one only single value, and then the pressure, relative volume, we have oil density, above the bubble point pressure, oil viscosity. That's it. Okay, so in CCE, we are only interested in the oil density and viscosity. Okay. And let's see how well the matching is. So if we expand this, and you can, neglect this right y-axis, okay? Just focus on first the left y-axis. In CCE, we don't have saturation pressure, no gas density. That's why you don't have green plus sign here. Oil density, indeed, we have. Okay, so it's like this. Or maybe we can uncheck everything first. Okay, and then let's select oil density. Okay, so you have the trend for the oil density above the bubble point pressure and the predicted values. This is the data above the bubble point pressure, and this is the predicted values. Of course, they do not match. Okay, but here above the bubble point pressure, our predicted values mimic sort of the trend. Although not the exact value, but we can follow the trend. Okay, so that's for the first property, which is oil density. Okay, this is oil density using equation of state as well as the standing cuts. Okay, liquid dropout, no. Liquid dropout, no. Interfacial tension, of course not. And then we also have relative volume. Very well. Okay, but relative volume is not that important for us to match. The most important things are the density as well as, of course, the viscosity. So let's see the viscosity. Where are you? Here we go, oil viscosity. Let's see. Yeah, so we don't have very good match here. Okay, we can sort of reproduce the trend for the oil viscosity. You see here, the lowest viscosity is at the bubble point pressure, and then towards the right, higher pressure, the viscosity increases, and towards the left, lower pressure, the viscosity also increases, and the highest viscosity will be at the lowest pressure. Okay? So, we can sort of reproduce the general trend for the oil viscosity in undersaturated conditions, although generally speaking, the results are not very satisfactory. Okay, so that's the checking for the, constant composition expansion. So by reviewing this, we now know that we need to improve the matching for the viscosity, of course, and then, of course, for the density. And this will shape the strategy for our regression. Okay, but we will not do the regression now. We'll be going to compare the matching quality for the differential liberation until finally we will reach the regression phase. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much and see you again in the next PVTP videos. Thank you.